Hello everyone! We are starting a free open lecture in our Discord. If you are a viewer and want to ask questions and get answers in an online format, join our lectures. You can find the link to the Discord in our Telegram channel. Adding to the beginning of the list, here we already have the complexity of the operation, from 1 or from n. It works similarly to a singly linked list, but now what do we need to do accordingly? To bind simply, the pref will be equal to num, and for the element that was, so to speak, at the 0 index, its pref will be our new element that we assign to the beginning. It is very important to check everything. The operation checks the list for emptiness. If the list is empty, it assigns the element to the beginning of the list. Otherwise, it refers to point 2. Point 2 adds to the beginning of the list when there are elements. If there is, for example, only one element, then it will simply set it as both the head and the tail. It creates a new element and assigns the next value in the new element. This is the head, which is currently the head. Then it moves the head to the new element. In other words, roughly speaking, it moves to the previous element from the head. It sets the previous value of the next element to the head, meaning we now refer to the next from the head, and we need to link the next to our new head. This part is a bit complicated in implementation, but it will be clearer as we go through the remaining list. We increase the key by 1, which is why it will start from 1 or from n, because in cases where the keys are not stored, everything will start from 1. When keys are stored, we will need to increment the keys, which means we have to iterate through the entire list. And this is important, because the keys must be unique. Accordingly, let's consider. If our head is empty, then in this case we equate all of this to a node and so on. We are considering all of this. This is what the initial node looks like. It has next none and pref none. We have already discussed all of this. Head is equal to none. That is, when our head is not empty, and for example we have a list like this. What do we say? We add some v to the beginning. Here, don't pay attention to the fact that v is also slightly at the end. We add v as if to the beginning. Here it is, the head, now pointing here. After that, we say that we move here. Now this is the head, and we say that now from the head next and its prev, this is our head. That is, we are restoring this connection. Now we will also notice everything. Then comes the iteration. That is, we go to x, then to y, then to z, and then to v, increasing their keys by 1. It's all very simple here as well. I won't explain the first operation either. It's just like in a singly linked list. Accordingly, it's basically the same here. If this didn't pass, then we do this. We create a new node. Accordingly, we say that the head is now this new element. Accordingly, after this, we must not forget that we should first say that her next node is our head. And we will do this right at the end.
Want to become a great programmer? Subscribe to our Telegram channel.
We passed it, and he immediately filled it in. Now we say that self-head is new node, meaning we moved the head to the new element, and now self-head next pref, which roughly speaking, means that from the head, the next element's pref is the head. So we are restoring the connection. This means that the pointer of the next element to the previous one should equal our head. Or rather, it should point to the head. It's quite a complex notation, but when you delve into it further and work on your homework, you'll understand it even better. A bit. Temp is equal to self, head. Next, yes. This is already an operation. We are increasing the keys by 1. Everything here is also very simple. I won't dwell on this any longer. And the last operation that we will discuss in the doubly linked list is checking for emptiness. It is completely identical to the singly linked list, and here there is essentially nothing that needs to be changed except that you should replace the root that we had with the head. Well, basically in a singly linked list, if you wrote everything using self.root, yes, the root, you can change everything to head. Yes, this will not be an error because it's just a naming convention. Generally, root is used where there are roots, heaps, etc., and so on. Accordingly, it would probably be more appropriate to rename everything to head to avoid confusion. In principle, that's all. Let's take a look at the code in Python right away. It is basically identical. The only thing I added here is that all operations were specified. Here is what has been added. We have a regular print. Yes, I expanded it a bit, and it means that the print is from the front, which is the output from the end to the beginning. So there we only printed to the end 3 times, and here I added another print from the end to the beginning for convenience. Checking for emptiness and so on. Here an extract is also written. You can take a look at it, as it will also be part of the homework. There are various checks here, and these are the operations that are applied for working with the prepared list. Everything is already here, yes, and I slightly expanded the empty function, showing how it can be written in 3 ways, but in principle it is the same. You can pay attention to this. This is the only change that has occurred here. In general, everything else is the same as with the singly linked list that we discussed at the end. And the homework. Now let's take a look at the homework. There will be a few more operations that you will need to write, because you already know the singly linked list, and you already know several operations from the doubly linked list. Accordingly, you need to write the remaining operations for practice yourself to understand it better. As for point 5, deletion, yes, it is indeed deletion. Well, the front deletion is exactly the same as in a singly linked list, but not. Don't forget that you now have a prev pointer that you need to update, and we also have a tail, meaning that the head and tail can be in the same place, which is also important to check. We have a search, and we shouldn't forget about checking the nearest head or tail. This means that if we have 100 elements, for example, if we are searching for the 5th element, it is obviously easier to start from the head, because we would only need 5 iterations in that case. And if we have, for example, an element like 97, then if we start from the beginning, we will perform 97 operations, while from the end, it will only take 3. Therefore, it is more convenient to optimize so that the traversal is in the middle. We either go from the beginning or from the end. Worst case is half. But there is no complexity like n divided by 2, because we consider this as O of n. Nevertheless, from the perspective of such micro-optimizations, it is very interesting and beneficial to do this, and try to write 2 methods. So the first is just a pass, either from the head or from the tail, as you prefer. The second is to try to create a combo option, where it also determines the length and decides whether it is more convenient to go from the head or from the tail. The same needs to be done with insert and extract. We also talked about how insert and extract work in a singly linked list, which you can refer to in those lectures to learn more in detail. The reverse operation is the same as in a singly linked list, and the step is also the same as in a singly linked list. Shuffle is a slightly new operation. For example, if I have a list, I will call it DLL. Roughly speaking, it looks like this. And what does it look like? 1, 2, 3, 4, 5 at the moment. And then what do I want to do? I want this one to be inserted in the center as 1. Yes, roughly speaking. Then, the 2 should be inserted on the right. On the left, a 3 is inserted, then a 4 on the right, followed by a 5 on the left, and so on. If there is an even number, for example, if a 6 appears here, it will simply be placed here, and that's it. So, this operation involves, roughly speaking, having a 1 here, a 2 should be here, then to the left of the 1, a 3, and then we throw in a 4 on the right, a 5 on the left, then a 6 on the right, and so on. How is this conveniently done? First, you will scatter everything in a regular list as you need, through concatenations, and then you will save it all into your doubly linked list, DLL. It can be written this way. It depends on what is convenient for each person. That's it. Our lecture has come to an end. Don't forget to subscribe to our YouTube channel, follow us on Zen, Telegram, and all our social media, and keep an eye on our website. There's a very large update on our website, updating images and materials. We expanded and opened another new block, which will include iterations, separating the powers, and so on and so forth. Everything you need for interviews and preparation, for programming competitions. Good luck to everyone. See you at the next lecture.
Want to become a great programmer? Subscribe to our Telegram channel.